Good day. For this video, I'm gonna discuss about the domestic wastewater treatment and what are the processes being applied for treating domestic wastewater. This includes wastewater treatment categorization, overview of wastewater treatment system, primary treatment, secondary treatment, and secondary clarification. So domestic wastewater is the water that has been used by community and which contains all the materials added to the water during its use. It is thus composed of human body waste like feces and urine together with the water used for flushing toilets, sewage, which is the wastewater resulting from personal washing laundry, food preparation and cleaning of kitchen utensils. So why do we need to treat wastewater? Untreated wastewater causes major problems and damages to the environment and to human health. It contaminates good quality of water from bodies of water like river, which could also damage the habitats of other animals. Therefore, wastewater should be treated in order to reduce transmission of extra related diseases, reduce water pollution, and consequent damage to aquatic biota. Wastewater treatment categorization. First is a secondary treatment. Its primary objectives of secondary treatment are to remove organic matter and total suspended solids, or TSS, and kill pathogens. Most wastewater treatment facilities have parallel treatment trains so that unit operations and processes may be taken offline for maintenance. Advanced wastewater treatment or AWT systems are those used for producing a higher quality effluent that can be accomplished with secondary treatment. These facilities are designed to remove nitrogen and phosphorus through biological or chemical means, additional of BOD5 and TSS removals beyond those achieved during secondary treatment are possible. Most AWT facilities include some type of effluent filtration prior to disinfection, which results in lower effluent, BOD5, and TSS concentrations. Effluent from AWT facilities can yield the following concentrations depending on the specific unit operations and process used. Overview of wastewater treatment system. The alternatives for municipal wastewater treatment fall into three major categories: primary treatment, secondary treatment, and tertiary treatment. This is the degrees of treatment. First is the raw sewage falls into barack, grit chamber, equalization basin, primary setting, biological treatment, secondary setting, tertiary wastewater treatment, and falls into receiving body. It is commonly assumed that each of the degrees of treatment includes the previous steps. For example, primary treatment is assumed to include the pre-treatment processes, barack, grit chamber, and equalization basin. Likewise, secondary treatment is assumed to include all the processes of primary treatment, barack, grit chamber, equalization basin, and primary settling tank. So, primary treatment in its purpose is to provide protection to the wastewater treatment plant or WWTP equipment that follows. The major goal of the primary treatment is to remove the wastewater those pollutants that will either settle or float. Primary treatment will typically move about 60% of the suspended solids in raw sewage and 35% of the BOD5. Soluble pollutants are not removed at one time. This was the only treatment used by many cities. Although primary treatment alone is no longer acceptable, it is still frequently used as the first treatment step in the secondary treatment system. Secondary treatment system. The major goal of secondary treatment is to remove the soluble BOD5 that escapes the primary processes and to provide added removal of suspended solids. Secondary treatment is typically achieved by using biological processes. These provide the same biological reactions that would occur in the receiving water if it had adequate capacity to assimilate the wastewater. The secondary treatment processes are designed to speed up these natural processes so that the breakdown of the degradable organic pollutants can be achieved in relatively short time periods. Although secondary treatment may remove more than 85% of the BOD5 and suspended solids, it does not remove significant amounts of nitrogen. phosphorus, or heavy metals, nor does it completely remove pathogenic bacteria and viruses. In case where secondary levels of treatment are not adequate, additional treatment processes are applied to secondary effluent to provide tertiary wastewater treatment. These processes may involve chemical treatment and filtration of wastewater. Lastly is the tertiary treatment or advanced wastewater treatment or AWT. Advanced wastewater treatment processes produce a sparkling clean, colorless, odorless effluent and indistinguishable in appearance from high quality drinking water. They are used to prepare tertiary treated wastewater for use in recharging groundwater aquifers, indirect potable reuse, surface water augmentation, and direct potable reuse. The processes of use are often the same as those used for treatment of drinking water. Primary treatment that includes screening and grit removal. So this is the liquid treatment train of a wastewater treatment plant. This figure is a schematic of the liquid treatment train for a typical wastewater treatment facility. This wastewater treatment implies that a biological process is used to treat the wastewater. Process of wastewater treatment plant: screening, grit removal, preliminary treatment. Screening is the influent or untreated wastewater first passes through the borax for the removal of large objects and the other are debris, followed by screens with similar openings for removing of paper, plastics, hair, and rags. The material removed from borax and screens is called screenings. These residuals are usually disposed in a sanitary landfill. Grit removal. Screening is followed by grit removal so that inorganic particles such as sand, silt, grit, coffee grinds, and eggshells are removed. Grit is transported to a landfill for disposal. And lastly is the preliminary treatment. Flow measurement by a partial flume or some other type of flow meter typically occurs during preliminary treatment. Flow measurement is necessary to meet regulatory permit requirements and for pacing chemical feed systems. If necessary, primary clarification follows preliminary treatment. Secondary treatment. Activated sludge process. The aeration basin and secondary clarifier comprise the activated sludge process. Here, a heterogeneous culture of microorganisms consume soluble colloidal and particulate organic matter. Most of these substances are oxidized to carbon dioxide and water to produce energy for the microbes, and a portion of the organics is used in the synthesis of biomass. The secondary clarifier separates the biological and inert solids from the wastewater to produce a clarified effluent and thick sludge streams that is recycled back to the front of aeration basin. Secondary effluent then enters a chlorine contact basin or CCB where chlorine is added to kill any remaining pathogens into wastewater. The chlorine must be removed by some type of dechlorinization process before the effluent is discharged to a water body. Sulfur dioxide is often added for dechlorinization in the wastewater. So sludge treatment train for wastewater treatment plant. First is waste activated sludge. Next, aerobic digester, gravity belt thickener, transport to land application site. Waste activated sludge produced during biological treatment is processed in a sludge treatment train. A typical sludge processing scheme for WAS would consist of an aerobic digester followed by thickening with a gravity belt thickener prior to land application of the sludge. Aerobic digestion is a stabilization process that reduces the quantity of sludge that must be disposed of and also kills pathogens. Thickening with a GBT reduces the volume of sludge that eventually may be applied to an agricultural site for beneficial reuse of biosolids. Secondary clarification. This is the picture of secondary clarifier. If biological processes are to operate properly, it is essential that secondary clarifiers be designed correctly. For suspended growth systems, such as activated sludge, secondary clarifier must be designed to accomplish both clarification and thickening of solids. When mixed liquor from the activated sludge process enters the secondary clarifier, two process streams are produced. One is the clarified secondary effluent and the other a more concentrated stream called the underflow. Clarification relates to the removal of suspended solids that enter the clarifier so that effluent standards can be met. Thickening of biomass at the bottom of the clarifier to produce an underflow or thick sludge at solids concentrations ranging from 5,000 to 15,000 milligrams per liter is also desired. Increasing the solid concentration of the biomass reduces the volume of biomass that must be handled during sludge treatment. The performance of secondary clarifiers has a significant effect on wastewater plants, effluent wastewater quality, on the operational efficiency of the biological treatment systems, and on solids handling facilities. The secondary clarifiers have two key functions: clarification of biological treated wastewater and thickening and storage of the sludge from the biological treatment process. Main factors that impact secondary clarifier performance. First is the amount of solids retained in tanks, which is determined based on the concentration of the solids removed from these tanks, returned activated sludge, waste activated sludge, and the sludge blanket depth. The amount of solids in the aeration basins, which is established by measuring the MLSS concentration and the RAS flow rate. The activated sludge settlability. The plant influent flow and waste load significant fluctuations of which may result in shifting solids between clarifier and the aeration basin, then ultimately in solids loose with the secondary clarifier effluent. In addition, second clarifiers are inseparable and integral part of every conventional wastewater treatment plant. Their performances efficiency is affected by the upstream wastewater collection and treatment facilities and has a significant impact on downstream biological treatment and solids handling facilities. And this is my report for this video.